Now if you notice the drawing actually had an error in it, this center hole should go deeper and it needs to go all the way through into this cross hole. So we're going to go to drilling, we're going to drill, we're going to select from our tool library the number 11 tool, which is the number 16 solid carbide drill for 1032 forming tap. We're going to select that tool. 4,000 RPM is fine. 16 inches a minute. Again, round this up to 40 for retract. Geometry. We need to select our tool orientation, and it's going to be the same as what we did before. We're going to do Z-axis and Y-axis. So we want to select the face, and then our Y-axis this direction, and we want to flip our Y-axis. This needs to match the previous segment. So if you're confused, go back to the previous segment. Make sure that the axis orientation is the same as what you see on this screen. Otherwise, the table's going to rotate the wrong way. You'll still be able to drill the holes, but you won't be able to see them. They'll be on the other side of the part. And now we're going to select our geometry. And it will do the holes in order of the depth that they are. So the fact I modeled the one in the middle deeper gives it the clearance to go all the way through. Alright, so we're going to go to heights. We're going to go from stock top. We're going to deselect fixture top. And we're going from the whole top to the whole bottom. We're going to break through at the tip, and we're going to go an extra. So this is a 32 thread pitch. So if we need to go 4 or 5 threads deeper so that our tap doesn't hit the bottom. So we have 1 divided by 32 times 5. So we need to go 156 thousandths approximately deeper. Into the hole with our drill bit. Okay, and our cycle is going to be a deep drilling cycle again. We're going to do, 40 thousandths is a smaller drill, so that's 40,000 steps is good. Okay, so then we got our drills. Okay. All right, now we're going to move on to our tapping. We're going to drill. We're going to select from our library our 1032 form tap, tool number 14. We'll leave it at 500 RPM. I don't like pushing taps, they break and then you have a bad day. We need to set our tool orientation first. So again, we're going to do Z and Y. We're going to pick our Z-axis orientation. And flip the Y-axis, and this needs to match the previous operation. So if you are not sure, go back and check it. Alright, we need to select our geometry. So we're going to select our holes. If you have chamfers, you're going to want to select those because it sets the top of the hole. Then we're going to go to heights, and again we're going to stock top, but we're going to deselect fixture from there because that's pushing it way higher than we need. Okay, we're going to go from top height, we're going to go from whole top, we're going to go whole bottom, and then we need to go, so we're going to go four times deeper, not 5 times, so we don't want to go all the way to the bottom. So remember, it's 32 threads, so in 1 inch we got 32 threads, and we're going to go 4 times. And so we're going to go an extra 0.125 deeper. And that way it ensures we have fully formed threads for what the whole design was. We're going to go negative 125. Okay, we're going to go to our cycle. It's tapping. We'll leave that at default and hit OK. Okay, we now should have made all of the features we needed on 5-axis. Now, the next setup is going to be op3. We're going to go back to a traditional 3-axis mill. Mill the back off, drill some holes, do a chamfer around the outside edge, and this part will be completed. Okay, here we go. We're on our last setup here for this part. We're going to put it back in a traditional mill. And we're going to mill off this hat and put on the chamfer. Alright, so let's make a setup. We're going to do a new setup. We're going to select the model of the part number. And we're not going to use stock box point. We're going to use the Z-axis plane and X-axis. So I'm going to pick the face of the stock, and then we're going to have to hide the stock. And we're going to be using a model box point because we've already machined the base of this thing. We want to base our registration off the machined part, not the stock, even though we've got this hat on top. So I'm going to pick the left-hand corner, and our X-axis, this looks like it's going in the correct direction. So how we achieve this is we're going to set up 1, 2, 3 block on some parallels. You're going to edge find or probe on the corner of that block, and then use the top for your Z height, and then take the block out, and then we compensate 1 inch for the thickness of the block. Okay, so now on our stock tab, we aren't going to use it from the previous operation. That was a full 5-axis move. We'll go ahead and go from solid, and we're going to select our stock model for that solid. Okay, we're going to post process. We're going to call this 3023, the third operation, op 3 for VF1, and we're going to just use work coordinate system 1. And let's go ahead and change our name so it's consistent. Okay, so now we're going to use a face mill. We can actually rob the routine. We can copy it from op 1, paste it in op 3. We're going to have to do some modifications though. So the total amount of material we're removing is from the top of this dovetail feature to the top of our finished part. So that distance is 340 thousandths. So this face mill the geometry is fine. On the heights tab, we're going to start at stock top, and then we're going to, our feed height is going to be stock top, and our bottom height is going to be the model bottom, so that's correct. On the next page, our pass directions, extensions, that can all stay the same, but we're going to do multiple depths this time. And it'll be 60 thousandths for this cutter. And we're going to use even step downs. Okay, extra decimal point there. And we'll just leave it at that. That cutter does pretty well. We're going to keep all these the same. And hit OK to remove the hat on top. That's about right. Alright, the only other feature to make is the buzz around this thing and make this chamfer on here. We actually did that in op 2 You could rob it from there, but if we're going to, so let's open up 2, even though this is done on the 5-axis. Copy paste, we're going to go edit. We're going to leave all this at default, except for we're going to deselect the geometry we selected before. We're going to select the chain we want from this side. Go to heights. We can leave all this at default. Go to passes. We're going to leave all this at what we had our settings last because we copied it. Linking. Should be able to leave this all the same as well. Hit OK. And we have a chamfering around. Now in reality this material's not here. That's already been milled away. And that's it. That's it for this part. So what you need to upload is 3 setup sheets and 3 programs. I want to see a program for your prep op, your 5-axis work, and op 3 should be back on a traditional milling machine, 3-axis milling machine. Once you have all that, you'll run a proven program for op 2, and op 3 you will run your own program on the machine, and you'll set up on a VF1 to finish that off. Thanks a lot, and I'll catch you on the next one.